Sanchez and I partnered with the CEO of a private equity dental practice to improve his bottom line through predictive analytics. And along the way, learned quite a bit about churn modeling and the inherent challenges of incorporating machine learning into a business. A little bit about myself. I'm a former SEAL, turned data scientist. Spent a few days in some very hot and humid places of the world before getting out in 2017, and spent 3 years in sales and operations roles before making this full-time pivot into data science. When I can, I try and fly fish, rock climb, and snowboard, and actually try and get some machine learning done during the day as long as my daughter and her friends aren't bothering me. So the CEO and I shared this belief that business plus data science equals better business. So to that end, I agreed to build him a churn prediction model that would allow his staff to take a proactive action to prevent someone from churning. And then on the back end, if someone did churn, allow them to take a reactive action to decide which patients to contact first. So churn, this is why it matters. Churn is expensive, especially to a small business. In this particular case, the practice stands to lose about $62K a year at their current churn rate of about 46%, which is actually quite high. It's about double the national average. So if we can, if this model can even do 10% less than they're currently doing, it'll save them about $15K a year. No small chunk of change for a small business. The data that I had access to was the entire practice's data set, which was in a MySQL database, over 300 tables. I didn't need to use all of it. I put the more important ones that I used here. And something to note is I didn't use the entire time frame. I focused on 2016 to the present, just so that the churn predictions were accurate and relevant to the future. So the problem they have is this churn, and I like to call this slide my smoking gun slide. And I'll tell you why in a second. But I've used the word churn a bunch of different times, but I haven't defined it, and it's going to be defined differently across industries. In this case, we're saying churn is any patient that isn't seen within the last 400 days. And as you can see here, the people who don't churn tend to stick around for 4 years or more, but those who do tend to be what we call this one and done case, where they show up once to the dental practice, they're seen, get their teeth cleaned, and then they're never seen again. So that's this big blue hump you see here. And the idea is that the churn prediction model will allow us to predict which ones are going to churn, and then be able to take a proactive action, thereby lowering out this or smoothing out this curve or this hump here. So the solution ended up building a churn prediction model for him that ended up being a logistic regression model, which performed quite well over the baseline, about 33% improvement. And in addition to that, so it was able to identify about 83% of the people who were identified as churning. But in addition to that, the model allowed me to kind of suss out which of those features were contributing to that prediction. And one of the more insightful findings that I found was that it mattered who the hygienist was. It mattered who the patient saw, and which was not, I was actually quite surprised by that. So after looking at that, I actually went back into the data and calculated the churn rates for each of these providers here, and found that provider 1 and 2 had double the churn rate compared to some of these other providers here. So this isn't a causal model. So I wouldn't recommend to the CEO, hey, let's go fire provider number 1 and 2. But that is something that we want to look into further, especially given the large discrepancy in the churn rates. So I mentioned that for them to be able to take action, they have to be able to see the results of the churn model. So I built an app, and this is the receptionist staff would log in, and this is what they would see displayed. This ranks the top 5 patients sorted by risk factor. So it's identified Vincent here as the most likely to churn. And for privacy reasons, his contact information isn't listed here, but the staff would see it, and they'd be able to either write him a thank you note, send out a text, or give him like a $50 discount to come back and make a next appointment, taking an action to prevent him from churning. On the back end, in the event that someone does churn, then they have this prioritized contact list. There's an algorithm that sorts these patients into bins, customer segmentation, with the idea that not all patients are equal. Some are more valuable than others, and this algorithm sorts them, ranks them out accordingly. So in conclusion, the model allows the staff to take a proactive action to prevent churn, and then on the back end, basically provides a sorted, prioritized action list that they can decide on make a decision on which patients are the best to contact. Thank you for listening. If you have any questions, feel free to ask.